Hey guys, so welcome to another C++ tutorial. In this tutorial video, we'll be talking about arrays. They are basically uh, some contiguous amount of memory that you want to allocate. Let me clear it out. So let's just create a file. NVim is my text editor that I've been using for these videos. So NVim array.cpp, and let's just write some boilerplate code before we start delving into what arrays are and so on. So I will include stdio for this, and I will say int main, and that's it. So what an array is, let me clear it out first. In the previous ones, we have whenever we needed some memory, what we did is we declared some variables, right? Like A, B, C, D, and so on. But the problem is that like having all these names and referring to all these names are sometimes like not so good of an experience, and somewhat that all these things belongs to the same kind of data, and I can just provide the name and I can say that okay, from this name give me the third variable, or from this name give me the fifth variable that is of the same type. So to solve that issue, there exists this memory type called array. An array is nothing but a contiguous block of memory. What contiguous block of memory means is that in your memory, in your RAM, the numbers are stored one after another. Okay, like this, and there is some blank memory might be, then there is some other numbers. Okay, but the idea you understand that the memory is stored one after another. So what I can say is I can say that okay, give me the second number. So it will go to that particular variable's location and it will provide me the second number. In this case, this number. Let's see an example of how you can declare an array. They can simply be declared like ordinary variables. I want an array, so I just say will arr, whatever name you want to give your variable, and then you can provide the particular index of like how many numbers of elements do you want. So in this case, let's say I want five elements, and the elements being this, and this is called an initializer list. Whenever you are declaring some values for a collection in C or C++, you might be using this syntax, the values provided in the, or the items provided inside a curly braces. So this is called a initialize a list. So this is how you can initialize an array, and you can simply just look through that array and you can print whatever the values were there in the array. So I can just simply compile that array.cpp. It compiled successfully, and then I can just say that okay, as I have compiled and given me this array.executable, CL is the compiler provided by Microsoft Visual Studios. So I can just run this program by calling this particular function, and you can get that these are the numbers that were in the array. And as you can see here, the first time you give the number, it's how you declare an array with its size. But the second time, whenever you give it a particular index, it acts as particular which element you want to find. And also one thing to note, that sometimes even those guys who are working for a long time forget, is that not forget, but just to mistake is that arrays indexes don't start from one. Like if you want to, if they start from zero, like there's zero index. So the first element in an array is situated at array zero. The second element is situated in array at one, and so on. The last element will be at array four, not five, because it starts from zero. So that's why it's written that as I equals to zero, I is less than five. Less than five, the highest value of I will be four. Okay. So let's try to write an code where we will ask the user to put some numbers, and obviously they will be less than six, and then I will store those numbers, and then I will return the highest number that the user has given me. That's the goal of this particular program. So what I can do is I can declare an array of 10, and if you don't give the values here, what will happen is it will just give you some random memory, and whatever was written in that memory will be treated as integer, and you will get some garbage values. Okay, for example, if I just remove that and recompile this, and then I try to execute this, you can see I can get some garbage values. If you want that I don't want garbage values, but in most cases what you will typically prefer is that all your values are set to some zero values in case of integer or floats. So what you can do is you can simply say initialize the list 0. So this is equivalent to setting all the numbers to 0. You just can write this, and all the numbers that are present in your array will be treated as like 0 from the beginning. They will be 0 initialized. Okay. So that being said, let's write the program that we try to make. So we can just have an like int n, the number of inputs that the user wants to get. Then you can call the scanf function provided by cstdio. Cstdio provided as printf that printed a value, and scanf is used by to read a value from the user at runtime. What runtime means is that when the program is being executed, there are two times. One is not times. I don't know what they are called. One is compile time. Compile time means that when the program is being compiled, when I'm running that cl array.cpp or whatever command I am using, and the runtime is that when the program is executing. Okay, so this is just to distinguish that particular behavior, whether it's performed at compile time or at runtime. So scanf, as I have told you in the earlier video, it doesn't like take the variables as origin as like normal names, just as printf, but rather they put an %, in front of it to say that okay, give me the location, because what you want to ideally store is the value that is inside that location, and there is no way by just providing an particular variable you can store the value, because you need that equal to operator and so on, and we will get to that later. But for now, just simply understand that scanf, it takes the location of the variable. In that case, you just put the %, in front of it, or just use a pointer, and that's how scanf performs. So now that I have all the numbers that I want to get, what I can do is I know that the user is going to give me n numbers. So even I can prompt the user that I can say that printf enter number of elements. The contents of the array is generally referred as elements of that array or items in that array. And then I can get the value n. Then I can look through n numbers from 0 to n minus 1. And I can scan if x and put it into an array. A easier way will be just scanning that value directly to that address of the array. So I can just say address of array I. And once I have that, what I would like to do is I would prefer to get the maximum number of it. So for that, I can declare a maximum value like int max val or something like that, and I can set it to the first element of the array. And I can look to the rest elements of the array. So I will start from 1 and go to n minus 1. And if every time I will check if the number that is present in that particular index of the array is greater than the number that was already assigned as max val, then I will update the value of max val to be the number that is present there in that particular index of the array. And once I'm done, I will just say printf the max value is this. So this program should ideally work. I can just say cl, and this will compile, and then I can execute it. I can give a number like I want to look into 5 numbers, the numbers being this. And as you can see, this is the number that is highest. I can try it once more. This time I will give like 7 numbers, they being like this. As you can see, this is the greater number. So this is a simple program which finds the maximum of a particular given series of numbers, and whenever you need to store a given of series a series of same type, you're going to use array. But one problem with this thing is that in this case, how whenever you declare an array like this, it's declared at the stack of the program. So as I have told you earlier, whenever a program is being executed, the RAM memory that is used by the program is separated into two sections. One is the stack section, and another is the heap section. Whereas in the stack section, everything has to be placed one after another. The variables you are declaring, they're being placed one after another. So in that case, you have to specify the amount of the memory that the array is going to take at compile time. That means this 10 can be a number, can be a constant, but you can't take that number from the user and use it as a variable and then put it here. Okay, that will not be viable. Like if I say it like this, for example, that I just put n here, it will not work. Okay, because at compile time, the compiler will not know that what the value of n is, so it will not be executed. Okay, so be aware of that. So to mitigate that, there are two ways. First of all, in this case, what I did is declaring such an array which is much larger than what the user might give, or the process you are trying to do is having. The another way is that instead of declaring the array like this in the stack, you can simply declare it in the heap memory itself. So to do that, what you need to do is first of all remove all these lines, because it will create compiler error. And apart from that, what you would probably prefer is declaring the memory in the heap itself. So to do that, there are multiple ways. The easy, the standard way is that using this library cstdlib, which provides you a function that allows you to access the system allocator. It's called malloc, malloc. That stands for memory allocate. And how many number of elements I want to allocate, you give it first. And the second is that each the total number and multiplied by the particular size of a particular variable. In this case, I am declaring integers and I need 10 integers, so 10 times size of the int. The size of is an operator. It's not a function. You should be careful about that. Like if I write this, it's also value. Okay. So size of is not a uh, what do I say? Size of is not a function. It's just an operator. But like with every operator, you can also use brackets. Okay, to specify that. Okay, like to be more specific. But still, it looks like a function. It has a name, so we prefer to do it like that. And what it will do is it will allocate 10 integers out of space. Okay. So in this case, I want n integers out of space. So what I will do is I will probably put it down here and here, because and also like whenever you're using malloc, you will probably use it as a pointer. Okay. Pointer is nothing but same as arrays. It's just like also the what arrays does is it just stores like every variable where the variable starts in the memory, nothing else. Okay. And you can use them interchangeably. Only the writing convention changes, nothing else. Okay. So in this case, I am declaring a memory that is worth of size 10 integers, and that is being stored as an array, and the rest of the thing is same. But whenever you're declaring some variables with malloc, you probably would like to declare them as a pointer, or you can just simply write this also, I think, because this means that I don't know how much memory is there at the compile time, but I don't know. Okay, so they don't allow in C++, but in some languages you can also declare it like this. Like I think in Java you can do it like this way. Another way, if you think that this is looking too much ugly, you can just simply say new, which is equivalent to calling malloc, and then you can specify the type and how many elements you want. So in this case, new integer of n, new n integers. This is same as malloc, but once you have done with dealing with your array, you would probably like to free that array. So you can just call the function free, because whenever the stack is being executed, the memory is all is allocated and deallocated by the program itself. So you don't need to care about whether you have freed that memory. But in this case, what you would prefer is that you free the memory after you have used it. Okay. So you just call free function and you provide the memory. If you don't do that and if your program keeps allocating memory, it will just fill your RAM. Okay, at some point of time you will like run through all the memories that you have available. In that particular scenario, when you are not freeing your allocated memory, and memory is being allocated at a lot, like one after another, is called memory leak. It's one of the basic problems whenever you are working with languages like C and C++ that don't have a garbage collector. Okay, but it has its own benefit. Okay, as long as you are careful of freeing that memory, you can do that. Another way you can do it is simply you can just say delete by, and you can provide this curly braces to specify that okay, I'm not deleting one pointer, but the pointer what has been declared is actually an array, and obviously you need to put an asterisk here, because that's why it will be treated as pointer, and pointers, as I am telling you, are same as arrays. There is no difference. Pointers are just dynamically allocated arrays. Okay. If you have one variable there, then you can just call delete. Like if you just create one variable, you can just call delete. But in that case, you just don't provide this. Okay, just say that it's a new integer. Okay, probably you will like to put a bracket, like parentheses, but it's fine. So coming back to the previous example, like this, what we can do is we can run this code, and it will probably, let's clear the screen first, and it will probably give us the same output. Sorry. So I will try to compile this. It compiled successfully. And now if I try to run this, it will ask me to give some elements. In this case, let's give it 10 elements because I don't have any constraint anymore that how many numbers I can go through. So I will just give them some elements, and it will give me the highest number of elements that I had. So that's the basic idea behind using arrays, or nothing else. We can go over the other stuffs later. But let's say I have an array. Okay, let's remove all these things, and let's talk about like the relationship between arrays and pointers a little bit. Okay. So let's say I have an array and I want to pass that array to a function. The easiest way to pass that array is in the function, and the easiest way to like use pointers is that just treat them as arrays, just the declaration convention, nothing else. So you can just say that I have int array uh, or arr whatever, uh, and it has, let's say, 10 elements or 20 elements, the elements being this 0, and then I can just assign some random variables there, that array I is equals to, let's say, there is also a function provided by cstdlib called rand, which provides me a random element. So I can call a random number, I can call rand, and in this case I don't want the number to exceed thousands, thousand. So what I can do, I can say that modulus it by 100,000. So like after dividing by 1,000, whatever number is there, just assign it to that array. It will give me some random 20 numbers, for example. And what I would like to perform is like I want, for example, give this to a function which will return me, in this case, the average of those numbers, for example. And probably because you are using this time I will use float, because otherwise in case of integers, the rest of the part is being deleted like after the point, so which that doesn't deal with decimal numbers, so we'll use the float numbers, and the rest of it is same. Okay, so I have zero initialized the array, and probably because this is a floating point number, what you can do is you can simply do this will also work. The reason being that whenever you use equal sign, the compiler is smart enough that you are putting an integer into a floating point number, so it will convert that integer into a floating point number and so on. This process is called typecasting. Okay, there are different types of typecasting: implicit typecasting, explicit typecasting, and so on. But this is explicit typecasting because you are not telling the compiler. This is implicit because the compiler is deferring it like by itself. If you want to be explicit about that, you can just simply say, just declare the type in the front like this, and that's it. Like you can wrap that variable in a bracket, and you can say that, okay, my variable whatever you have given is of type float. You can even remove these brackets and it will act as a function, will look like a function, but the idea is same. Like this is called typecasting. Okay, if you want to convert a variable from one type to another type, this is how you do it. Okay, so in this case I will have array of like random floating point numbers, and I can just print the numbers whatever was given to me. I can write it in the same for loop, actually. So I can just say print like percentile d followed by a space, and then whatever number I had created, and then after that I would probably get a new line, because why not? I don't want to write in the same line, and then I have a function where I want to pass that array. That's the like thing that we want to implement, right? Passing that array to a function, like how we used variables. In this case, as I told you, like arrays are pointers are same. You just pass them by as a pointer. You can pass them also as an array, but I would prefer that you pass them as a pointer, and you also specify that these many number of elements are there. So I will say that find. average. I don't know if the spelling is correct. And the one way of doing is that you just say int array, and like you can put this. It doesn't need to be the same number. I can just say a in this. This is how you pass an array to a particular function. But also what you can do is you can just say int star. This is what I prefer to do. I just makes things easier for me, I guess. And then you provide the number of elements that are there. Like in this case, I have n elements, for example. This n does not need to be like that n, but you get the point. And then I have the sum here, which and obviously this function returns a float, and also here this will be float. So once again, this will be a float, and I return the sum divided by n. And because the sum being a float, this division will work correct as far as I know. And then what I want to do is I want to call that function that float average is equals to find average. I provide the array along with how many elements are there in that array, and then I can simply call that print the average value that I found. Okay. So now if I run this, if it compiles successfully, and as I have done, I have written print. It should be printf everywhere. Okay, but because I am a lazy guy, I sometimes forget things. That's it. Like no programmer is perfect. If someone is like writing everything like perfect, then either he is a like godlike guy, or maybe he just has that code written somewhere and he just copy those things. Anyways, that's not the goal of the discussion. So just compile this array.cpp, and once again I get another error that is saying that is not a valid left operand for type float. So one thing I forgot to mention is that this modulus operator, it only works on integers. Okay, sometimes also chars, because characters, because they are also like acting as integers, and like other families of integers like unsigned and so on, but they don't act on floats because there is no like purpose of like there is no operation of taking modulus of a float. Okay, it just doesn't make any sense. Okay, so I think that this is good enough. So we can just compile it, and once again the printf, I put percentile d here, which means that these are arrays of this is an integer, but as you can see I am providing a floating point number, so this should be percentile f. Okay, so that being done, I think now I have a little less uh, errors. And what it's saying, you cannot you convert argument array from float this to integer this. Okay, integer pointer. Okay, so nowadays the new versions of compilers, they are getting somehow extremely smart. You don't know why, but all you need to do here is just say that my array pointer is equals to array. Okay, I guess, and then like I just pass array pointer. Like there is no reason of like rejecting this. Okay, there's no, many compilers will just accept this. So anyways, what I was trying to say is now if I compile it, it will say initializing cannot convert float to an int pointer. And once again, oh sorry, the compilers are already smart enough. I am a fool because these are floats, not integers. I will just say float pointer again. Okay. So once again, if I try to compile, it will say that a pointer is not defined because I didn't pass the array, but I passed the variable that is not declared. So I'll just pass array here, and if I compile it successfully, if I can try to compile it, now you can see that it's successfully compiled. And if I run this, it will. These are the numbers that were provided, and this is the average. Now you might not want all these like values after that. So what you can do is you can simply whenever you're printing a floating point number, you can also provide that after decimal places how many numbers you want. So after decimal places, let's say I want only two numbers to be shown. The same goes for here. After decimal places, I want only two numbers to be shown. So I can just put point two here. I can write this, and if I compile this, This compiles. Let's clear the screen. And if I run this, you can see that after decimal places, two values are shown. And if you take the average of these particular values, whatever been created, the average will be 555.35. Okay. So that being done, uh, and as I have told you, you can also like do this, like float this. Okay, this is also valid. Now let's say I don't want one dimensional array, but I want a two dimensional array. Okay. What that means is like I want to declare a matrix, for example. So what I can do is I can just give another dimension here. Okay. Like 20, for example, float array 2020. So it will be like um, an array, a matrix. Okay. So this is how you can just declare a matrix. I'm not going to write a program on matrix right now to get the picture. That you can give multiple indexes, and whenever you are writing it as such, you just access them by providing the different indexes. Like I want the number at zero, like the first row. Like you can think of these as rows and think of these as columns. Okay, so I can say that at the zeroth row, the fourth number, because 4 minus 1 is 3, and it starts from 0, is a 1. Okay, and I can write a program which can print that array. So I can just write void print matrix, because this is a two-dimensional array, and you provide the sizes like this. If you are providing like multiple arrays, the last one you can forget about specifying the indexes, but the rest you have to specify the index in this order. Okay. So what it will do, it will just simply print all the floating values in every row. Like it will go to each row by I, and then on each column present in that row by J, it will print array IJ, and then it will print a new line. Okay. So now if I print this, like print this array, this two-dimensional array of size 2020, mm, it will throw me some error, obviously, because array is missing subscript and so on. Cannot convert one from floating, etc., etc., etc. Because once again, I was explaining to you, and I didn't look into it completely. So, like this is not a big issue, and also like I don't want after two decimal places, so point two I will provide here. But apart from that, if I put 20 here, does that satisfy this guy? I don't know. Like, might be he might be satisfied with that. Uh, let's type it. Okay. So cl array dot cpp, and it compiles, and then you can say that run that array, and as you can see, in the first row, the third element is set to 1.3. Okay. Let me give you another example. Let's make them a little bit shorter. So I can just simply say this is a constant value. So constant mat size will be like 5 by 5. Okay. And everywhere, instead of lighting this, I can say mat size. Mat size. Okay. And I can simply just say array mat size, because this is a constant value. It will work. And then mat size, and then also I think you might not give the first value. You can just let it as array. I forgot to put it last way. The best way is to you experiment it yourself. That will make things more easier, because everything is in mat size. I can just forget about this int I and j, because I know that it's of same size of rows and columns. So I can just say mat size, and this is also I can declare as mat size and mat size. And the third element of the zeroth loop, set it to 1.3, and the second one, let's set it to 22.4, for example. And now if I try to print that array, if this throws a error, then probably it's not how you are supposed to provide. I don't know. and it's saying that it's showing some other error saying that aim is not declared. So I think this actually works. Yeah. So this will be also matrix size, not size. Okay. So now if I compile this, it will compile successfully. And if I not open this file, but if I try to run this, you can see that the 03, the fourth number from this position is set to this, and then 1, 2, that is the third number in the first row is a second row is set to this number. So this is how you can deal with multi-dimensional arrays. You can go even further, like 4 dimensions, 5 dimensions. You need to be a little bit clever to print them, or you might not need to print them at all, but you can do it. So the first index you might not just provide it, and rather you will just provide it as a like second argument, because obviously you need to put the second argument here. Okay. So that's how we do it, but that's not how I generally prefer to do it. So I will show you my way of dealing with multi-dimensional arrays. I will show you the two-dimensional one, and the multi-dimensional one is you can take it as an exercise. Okay, if that makes any sense. So what I do is I typically say that this is my matrix, okay, insta matrix, and then I just declare it like this. Okay, like you can write like it's a two-dimensional array. So I have two like total, if m times n, like I want to declare a matrix of n size n. So let's create a function for that. So it will separate the code, and you will also understand like how you deal with big amounts of codes. So I want to create an integer matrix. Okay. So I will call it int star mat create matrix, because it provides me a pointer which is as same as array. We will talk about it a little bit later, and I will say that I have these many rows and I have these many columns. Okay. So what I will do is I will just simply declare that like this, that int star mat is equals to, then I will say it's of integer type, and malloc row times columns times size of int, because that is the amount of data I need. If you think of it like this, that like I have these many amount of elements what I can see, like, but what the compiler sees is like it's this repeating like this, and also there is no gap, so it's just this. Okay, it's up to me to decide how I treat that data, but at the end of the day, it's just a continuous amount of data. So it's just up to me. So that being done, next what I would like to say do is I will just want to set everything to zero. So I will call a function called memset. Okay, it's this memset is also provided by cstdlib, just like malloc and free. And what it does, it simply sets all the values to given value, in this case 0. So first you provide the starting address, the pointer, that is this matrix, and then the value that you want to set it. I would not recommend to use memset with anything other than 0 if you're working with integers, and because this is just the size of every byte. Okay, you have to remember that you can from 0 you can give up to 255. Okay, in memset, because it's just setting the every byte, and how many bytes are there, obviously this many bytes. What malloc takes actually is how many byte of memory you want to allocate, nothing else. In the next video we will talk about pointer and pointer element arithmetic, so we will get this like demystified even further. For now it might seem a little bit complicated and overwhelming, but that's how life is. So now we can create a matrix like that, and we can of any size. Like I want to create a matrix of like size of 3 and 4. Okay, let's not just do that. So this creates a matrix the same way, because the AI is smart enough. If I just ask him to print a matrix, it will print that matrix. Okay, given the rows and the columns. And also I want to write a function called add matrix. So void add matrices. It will take two matrices. Okay, it will add them together and put it into another matrix. But I don't want to put it here. I'll just return it as this like. mm, int star is my output, and I can just declare it here that instead of my matrix 3, it's just create another matrix and then just return that matrix. Okay, and go through each row, and for each row, for each column, what you want to do is you don't want to ever write it like this, because like in later videos I will show you that it's a nightmare for breakpoints. You should always put your statement in next line. Okay, it does not matter that you give these brackets or not, but just put always your statements in the next line whenever you're using a for loop or a if else statement, because otherwise, when you're putting some breakpoints, it may affect your performance. So now, as you can see, I can declare two matrices like in star M1, and the matrices should be of the same size. So I will create a matrix of size, let's say 2 comma 2. Okay, and then I can set another matrix of like 2 comma 3. Let's do it that way, so you get the idea. And so let's store some values. So of M1, the first like I just want all the values in M1 to be 0. So for I is equals to 0, I is less than, yeah, this all values of M1 is 0, and all the values of M2 is whatever it has given me. Okay, I'm happy with it. So I'll first print M1, then I will print M2, and then I will add them into M3, and I will then print M3. And once I'm done with that, I will free M1, I will free M2, and I will free M3. A good idea of keeping your code clean is that not a good idea, sorry, a good idea is that if you know that you are going to free the values at the end of the your program, you don't need to write free, because once your program gets executed, the execution is done, this will be freed automatically. Okay, your operating system might not be that stupid to keep that memory. It's not actually that stupid. And also, like you can also like writing, rather than writing this thing too much, like this big amount of statement, what you can just do, you can just say new and row times call. Okay, it's the same thing, but it's a little bit slower, because like it also does a null pointer check. When I will go to pointer arithmetic, I will show you. But the idea to show you is that the arrays and pointers are the same. So rather than just using arrays and spamming brackets whenever you are passing them to anything, you can just use a single contiguous block of memory, and you can treat it however you want. Okay. Now this part is very interesting. Is that when you have a two-dimensional matrix that I wanted to talk before like it already wrote the program, so I did it. So you have like your total number of rows is, let's say, R of a matrix. Okay. And total number of columns is, let's say, C. Okay. So the index that will be equivalent, that index I is equals to nothing but R times the amount of columns that you have plus C. Okay. For example, let me give you an example. Let's say I have an array of let's say like I have an array that is actually like 6, 7, and 8. This is the size of the array that I have declared. But I want to access the array at position 2, 3, 1. Okay, this is the declaration. Let's say I declared an array like this, and then I want to access this position and set it to 0. Now what I am doing in this case is that I'm saying that, okay, I don't want this much numbers, just put them all together, just create this. That's what I'm telling it. Just put that all memory together. So how do I access this now? This becomes a problem now. So it's the same thing. Like you just say that, okay, I have 2, and 2 times the size of each row is what is 7, right? The second index. And then what I want to do is like how many of like there are 6 of this 7 times 8. Okay, and I want 2 of this 7 times 8, so it will become 2 times 7 times 8. Okay, plus I want the index that I wanted to access is 2, 3, 1 plus 3 times 8 plus 1. Okay. So the idea you get it. Like what I am doing here is that whatever index you are accessing, that index multiplied by all the other sizes of the other indexes. Like in this case, 2 times 7 times 8. Okay. Plus, in case of 7, I only multiplied 8. Like the second index, it has 8 elements. So I put 8 here. And plus, like in this case, 1, so on. Okay. So, like in case of multi-dimensional arrays also, you can just convert them into a flat array like this, flat memory, a contiguous memory, and you can use it. And it's very equivalent. Like whether you are declaring that as a three base array or four base array, like it doesn't make any difference. Okay, and this way you just like it might seem a little bit overwhelming to you. You probably will not be going more than two data points. So, for example, you will have like an array of size x and y, x times y. So every time you want to access, like if y times x will be better because y is vertical and x is horizontal. You can think of it like this. And every time you need to access the particular element is just I times x plus not I times x, like I times x plus j. Okay, if you want to access array I comma j, for example. Like this is not a syntax, but just to show you. Okay, this is actually syntax in the C sharp, I think. But if that's how you do it. Okay, it's equivalent to LIJ. So that's what that here the like it has been doing. Like it might seem a little bit overwhelming, and that's the reason that practice makes you perfect. Like you keep on practicing things, and it just makes you a better coder. Okay, you can go through all the poems in the world, but you might not become a poet. You can go through all the poetry lessons in the world, you might not be a poet. You can write a few poems, and you will become a better poet. That's the analogy that I want to give. But if I just compile this program, it says that memset identifier is not found. Okay, that's because I think memset is provided in a C string. I think, yeah, C string also includes memset, but it actually in memory.h. So C memory is the right word. Then it says that create matrix must return a value. I never return a value, so it should return a value here. So return mat, for example, here. And then if I just compile it, it compiles successfully. If I run it, you can see first one was 000 and it was added with 0 1 2 3 4 5 and the result was 0 1 2 3 4 5. I can show you that this actually works. This addition actually works by just changing the values. So let's for the first elements, let's not just set to 0, set them to 0, but let's set them to whatever row they are one. So it will be 1 1 1 2 2 2. Okay, sorry, 0 0 1 1 1. Like if I run if I compile this code now, if I run it, you can see the first matrix is 0 0 0 1 1 1. It added with 0 1 2 3 4 5, and the result it's saying is 0 1 2 3 4 4 5 6. So like this added with this is the same, but this is incremented by 1. How the matrix addition operation works. So the same way you can also implement matrix multiplication and all the other types stuffs that you can do with arrays. My advice will be that you just keep on playing, keep on finding issues, try to solve them, do some Google search, do some chat GPT question answering, and you will be proficient with arrays. And on other thing that I said you that arrays are pointers, the reverse is true, pointers are arrays. Okay. So basically, let's say I have a pointer like this. I have a like int star x equals to a new integer, for example. Okay, and then I can assign a value to a pointer by dereferencing it, as I have told you earlier. The first time, just like array, you were using indexes. For the pointers, it's the same. You just put a asterisk in front of it, and instead of having that pointer, a pointer is nothing but the memory location. So instead of having that memory location, now you have the access to the value. You can set the value, you can change the value, whatever you want to do, you can do it. And then you can just print the value whatever was present in the pointer. So in this case I will get 5 here. Like, if I compile it and if I run it, I will get 5 here. So you can see that it works. But the same way, because the pointers are basically arrays and arrays are basically pointers, you can just say x is 0. Okay. And it's the same thing. So like if you are like having problem with that particular like pointer distinguishing problem, you can just simply, instead of using star, you can just say that okay, every time I declare I use star, every time I use I just treat it as an array, and because it contains only one element in this case, I'll just put a 0 here, and that basically deals with it. But whenever you declare a pointer and you're not wishing that pointer to exist till the end of the memory, you must delete it manually by calling delete x. If it's a one value, then you just call delete. If you have multiple values, then you put an array here. And otherwise, you can just use malloc and free that I showed you. When you go through the libraries, standard libraries, I will take you through the other functions, all the functions that are available there. That's it. So I will end that in this session with like, well, there are too many things to tell, but I'll probably put this at the basic level, and in the next video we will go in deeper into pointer arithmetics and understanding like arrays and pointer. It's even more with some more theoretical talking. But if you want to deal with strings, how you do it? So one way easy is that you can say that I have a character of a fixed size. Let's say I have 100 characters, and I want to take the name, for example. So I can say that, okay, give me the string. Okay, so you just say percentile s, and you can just say that, okay, this is my character buffer, like str, where I want to store the string, and like I can read that string by simply calling scanf percentile s provided by the string, and the only thing that string is ended with a null character. Okay. So, for example, in memory, if I have like a character name, okay, and that name has like 10 elements, 20 elements, and that name is, let's say, John. So, what happens is that it's equivalent to saying that, okay, the name's first element is J, the second element is O, the third element is H, the fourth element is N, and after that there is a null character. So all strings in C, they are null terminated. So that's how we distinguish that, okay, this string is of this length. Otherwise, you need to provide n, like the length of the string every time. So to avoid that, they just append a backslash n after like backslash 0 or simply 0. Both works, both represent the same thing. But this means that this is a null terminated string. So this one thing, like writing this equals to John is equivalent to doing this. Okay, it's almost same. I can just print that string to show you, like print f name, and then I can take the input from another user, and I can also like for this string, and I can also print that string here, like let's put some backslash in here, and I can give it here. Okay, so now if I run this code, okay, and in case of string, because it's a pointer, okay, so it's already a location where the data is stored. We will get into that in the next video even deeper. But what you can do is you can just say this, and it will work fine. In case of strings, you don't need to provide that and percent in front of them, like as far as I remember. So I sometimes remember wrong things. That's also my problem. But if I compile this, you can see that it compiled successfully. If I run this, you can see that John is printed, and I can say that my name, and it's also printed, right? So that's how you work with strings. Strings are nothing but like an array of characters. Okay, just keep that into your mind. So I think I have dumped a lot of information in this video. So I will end this video here. It might seem a little bit incoherent, but as the other videos come and we keep on using these things again and again and again, it will become more simplified, and you will enjoy that. Okay, that's it. And like from this point of time, people think that okay, C and C++ are too difficult. I should probably switch to Java and JavaScript. But the idea is that they're not difficult. They just ask you that you need some practice, just like when you were introduced to calculus and those. All that meant is that you just need some practice because this is a little bit difficult concept to understand. So I hope this video helps you and it gives you a basic understanding of what arrays are and like what pointers are, which is basically both of them are same. So that's it. Thanks for watching. If you have continued this far, I don't think that anybody continues, but still, and keep on sharing these videos if you like to share it with your friends. But the idea is this: like I will go into the muds. I will show you. I will fail. I will try to fix those problems in front of you. I will show you that struggle that everything is going on. So it gives you a real understanding of what programming means. Okay. So that's it. Hope you enjoyed this session. Thank you.